Today you're doing Module 5, Lesson 13. Our objective is today you will relate manipulative representations to the subtraction algorithm, and you will use addition to explain why the subtraction method works. This is all a fancy way to say that you will see how vertical math and place value disk are related, are similar. You are going to use manipulative representations. That means you're going to use paper and pencil to show, to represent the math. And you're going to be doing the subtraction algorithm. You're going to be subtracting in these problems. And you are going to, lastly, check your work by adding to make sure that the subtraction method you use was correct and that the answer was accurate. Because remember, in addition and subtraction and any kind of math, it is important for your answer to be accurate. Otherwise, you've just wasted your time if your work isn't correct. So the first method I'm going to show you is a vertical math for subtraction. And parents, this is going to look extremely familiar to what we did, except that I've taught the students, or Eureka Math has taught the students to draw a magnifying glass over the whole or the biggest number in the subtraction problem so that they can see how this relates to this. So as you can see, I am crossing the number of ones in my drawing because I no longer have 5 ones. I added 5 more, and 5 plus 5 makes 15. That's how I got to that 15. And when I first drew this, I only had 3 10s, but I realized I didn't have enough ones. So I crossed out a 10 and turned it into 10 ones. I decomposed a 10. And then I only had 2 10s left. And when I end up with 2 10s, I cannot take 7 10s away. So I decomposed a 100. I took a 100 away and I turned it into 10 10s. And they can relate. They can see how this is the same as this. This is the way we learn to do it. This is the way they learn to do it. They are visualizing. You are able to see where you decomposed a 10 and turned it into 10 ones, where you decomposed a 100 and you turned it into 10 10s. We called it borrowing. They call it decomposing. So after I suggest that the kids begin by drawing their place value chart and their place value disk first. And as they decompose 10s, that they decompose in vertical form so that they're doing these two at the same time, but beginning with the place value chart first. And that is how they're going to relate. That is how they're going to see how this is the same as this. It is just a different way to see it. This is a very comfortable way for the children to do it. It makes a lot more sense. It's more visual, and it's what we are used to doing. We were doing it with 2-digit subtraction, and now we're doing it with 3-digit subtraction. And then after you're done with both your place value chart and your vertical math, your last step is to check your work. And students were taught the trick that if you take the 3 numbers in the subtraction algorithm, and you take the last 2 numbers, which are this is the whole, and these are the 2 parts. If you take the 2 parts and you add them together, and the 2 parts equal the whole, the number that you started with, then that means that you've done your subtraction problem accurately. These 3 numbers in the addition problem should be the same 3 numbers that they see in their subtraction problem. If these 3 numbers are not the same, that means there is an error in the standard algorithm, or there's an error in their place value chart, and they need to go back and check their work.